everybody had a good weekend. So
I spent a lot of time on PhD.
how'd it come out?
Effectively done. I have to do a few more comments just to kind of clarify and change some of the printfs, but I got a good functioning game.
Excellent, very good. So time well spent.
I wrote a lot of functions.
Cool, awesome. Good deal. So we're going to talk about functions this week, and the idea of using functions in programs like that. So you're probably ahead of the curve, which is always good.
Scott was good about cementing that into our head, use functions.
Oh, good. Excellent. Yes, good advice. All right. Well, I moved this weekend, so I'm in a house with my fiance and daughter, and have a new setup here. So I've discovered already that there's interesting lighting that changes depending on the cloud patterns. So so that's something. But the bandwidth seems to be okay so far. So that's holding up. And I can make changes if it becomes a problem, but I think we're okay. All right, so any questions on the stick program? And as I posted in Canvas, there's a sample executable under /tmp that you can run on the server to see what a working game should do. So you know how many sticks to play with, 25, and it plays the game as usual and wins. But you know the differences are you can specify the number of sticks here, and the other difference is you can mess up your response here as many times as you like, and so on, and then it'll still beat you. And the computer always goes first. But make sure you understand this business of picking the number of sticks. So if I say anything on the command line argument, that is my one and only chance to specify the number of sticks. And if I do something like this, game's over. If I do something like this, game's over. If I do something like this, game's over. Right? So if you put anything on the command, yeah, go ahead.
Do you have to print the hello statement and all that? In my game, if there's something wrong, the command line just says, sorry, wrong number of sticks or something, then goodbye.
That's fine.
Okay.
Yeah, so I'm not picky on the wording of this throughout. The only output I'm picky about is the way the stick picture looks, right? The pipes and the number and so on. But yeah, so if there's anything on the command line, then you're saying I'm going to give you the number of sticks on the command line, and if the user messes up, game's over. If you don't put anything on the command line, then you have exactly one chance to specify the number of sticks here, where it says how many sticks do you want to play with. And if you make any mistakes, or you just hit enter, or you put extra stuff on there, that's an error, game's over. So that's all spec'd out in the assignment write-up. But if you want to double check, what should happen if I say stick 0, you can run the executable from /temp and see what the expected behavior is. All right, so any other questions or comments on the stick program, PA2? All right, so let's see. Reminder that there's a online quiz which is due Wednesday morning, so this is listed as homework 3. And you could have done this at any point, right? There's nothing you have to know to do this quiz. It's really 4 questions that ask you that tell you to do something and then ask you to report what you observe. So question 1, you're typing in this code, and then you run the program and see what it does, and it'll do one of these four things. And this is, you know, code that's using scanf, which I said not to use, and we looked at that on Friday, or on Thursday. So type this code in and run it and enter hello and see what it does. And then here's a version that does input in a loop until you enter a correct value. You can go ahead and run this, put in the number 5, report what it does, and then go ahead and run this and put in the word hello and see what it does. And then the fourth question uses different code, and this is the code that's using this pair of functions, fgets and scanf, to do the ingest and parse in 2 pieces. And run this and enter hello and report what it does. And you can you know, shut off your brain and do these things just kind of blindly, but their purpose is to give you, you know, kind of a hands-on version of what we did Thursday, looking at scanf versus scanf. So it's most beneficial to you if you think about what you're doing and you try to understand ahead of time what this code's going to do, and then go ahead and run it and see what it does. And if it matches up, that's perfect. If it doesn't, think about, you know, why it's doing what it did instead of what you thought it would do. So you know, use it as a learning opportunity, in other words. But do it before Wednesday morning at 8. So
the scanf is literally the scanf function with the s modifier, right? If you go to
yeah. And it's just like scanf, except instead of reading from standard in or from some other input stream, it reads from a string. The assumption being you've already ingested from somewhere and stored the input into this string, this memory array, and then it parses from there. All right, so let's look at the next ODP. So this is ODP 410. This is a chance to play around with some functions, and a couple of notes. 1, this is due at 8 o'clock tomorrow instead of 10. And 2, my office hours are funny tomorrow. I put this on the schedule last week, so I have a meeting I have to go to from 8 to 9. So I changed my office hours from 8:50 to 9:50 tomorrow. But this is due at 8 regardless. So let's look at the README first of all. So you're writing a function, and your function is going to be called pick, and it's going to take an integer and return an integer. And guess what it does? The integer that it takes in, if we call that n, it returns n modulo 4, right? The remainder when you divide n by 4, unless that remainder is 0. If that's 0, in other words, if n is a multiple of 4, then this pick function returns 1. Right? Does this sound like anything that we've done or might be doing this week? This function? Does it ring a bell?
Like the stick program.
Yeah, this is the pick function from the stick program for the computer to decide how many sticks to take. Because whenever it's the computer's turn, what's it going to do? Look at the number of sticks left, take that modulo 4, and either take that number of sticks, or if that's a 0, just take 1 stick. So you could use this function in your PA2, your stick game, when you want to know how many sticks should the computer take. And if you've already written PA2, then you've probably already done something like this, either as a function or not. So the code is, you know, 2 or 3 lines of code, right? Basically take your number n, calculate n% 4. If it's not 0, return that. If it is 0, return 1. So it's a calculation and maybe an if statement and a couple of returns. What's more tricky about this is that this begins a new kind of style of one-day programs, where instead of writing a main program, you're usually going to be writing a function. And I'm going to give you the main program that is used to test your function. So this is something called a testbed. A testbed is something that you put, you know, something that you want to test into, and it exercises it. So if we were doing electrical engineering, right, there might be a circuit board with, you know, a bunch of connectors on it, and you're building a circuit, and when you've got your circuit ready to test, you would physically connect it into this circuit board, and you'd hit the test button, and it would run a series of tests, and it would light up, you know, a green light or red light for pass or fail. Okay, that's basically what the ODP is. The testbed is a program that I'm giving you. In this case, it's called /temp/odp410main.o. The thing that you're building that you want to test is a file called pick.c containing a function named pick, whose behavior should be this. So when you want to assess your program, your function, right, first thing you have to do is link it in with the testbed. And so you're going to do something like this: gcc-o pick, the name of your file containing your pick function, and then the name of the testbed, /temp/odp410main.o. And this will create an executable program named pick, which you then go ahead and assess in the usual way. Assess pick and the name of your source file, pick.c. So let's go through an example of how we would write a program, a file pick.c, and how we would assess it. All right, so I'm going to make my pick.c. So here's my beginning of my pick function. It's going to take a number n, which is the number of sticks. It should return how many sticks to take. And let's suppose I didn't read the assignment very carefully, and I'm just always going to take one stick. All right, so there's my attempt at a pick function. And if I go ahead and I assess this, right, I go ahead and I build my executable, and I assess it, and I grade it, and I get a big 0. So apparently I didn't understand the assignment correctly, or I didn't write my pick function correctly. All right, so this is obviously not doing what the README said it should do. So how do we develop this? Why is the prototype input int? As opposed to like int followed by a variable name, because the variable names are optional in prototypes. So you can put them in or you can exclude them. Yeah, it's kind of useful.
So if you exclude, if you just put int and you go down to your function, do you have to then declare whatever header you're using?
In your function, you have to have a name for the variable. If I just do this, I'll get compile errors. But when we'll prototype in a second, but the README, for example, says the prototype looks like this. You can do that, or you could say int space and put in a name for an argument, but that name doesn't mean anything. It's just kind of, makes it easier to read sometimes. All right, so let's develop this. So I think I've written my pick function, but it's not working correctly, right? So how do I figure out what's going on? You cannot just run this pick program because you don't know what this test bed is trying to do, right? It's not printing anything. It's you know, waiting for something, but you know, I don't know what this means, right? The test bed is not for you. The test bed is for assess. And your pick file, pick.c, all it is a function. By itself, it doesn't do anything. Right? You can't run it because it's not executable. You can't compile it into an executable because there's no main program, and you don't want a main program in there, right? Pick.c is just a function called pick. So if you want to test it, you've got to write your own main program to test it. Right? In other words, you have to write your own test bed. which is, you know, just a main program. So let's make a main program to test our pick function. So I'll make a main.c, and what am I going to do? I'm going to include standard io.h. I'll do a void main. I'll have an integer result. And I'm just going to call pick a few times. So I'll call it with a 2. And I'll just print out what my pick function returned. This should be result. Alright, this has nothing really to do with ODP 410. This is part of what you're doing before you hand off your pick file and say, here you go, here's my pick function. Right? And this is typically what happens, you know, in a work situation. You're working in a team. Each group is developing, you know, some set of code, and you need to test that code before you go ahead and add that to the repository of all the working code so that other people can use it. So if your task is to create a pick.c file that contains a pick function, you want to test it. Well, how do you do that? Write some test code. So pretty simple test here, right? Let's call pick with 2. Let's take the value that comes back, save that, and then let's just print a message. Pick of 2 returns, and I'll just print out the return value. And I'm going to do that a few times. So let's try with a 3, let's try with a 13, let's try with a multiple of 4, and let's try it with, I don't know, some big number that's a multiple of 4. Alright, so there's my test code. So now I can compile this. And I get a warning, right? So why am I getting a warning? It says implicit declaration of function pick. And it's pointing here at line 5. Okay, so main.c is the file, 5 is the line, 10 is the character position on that line. But it's showing me this call right here where it says pick. So let's go back to main, let's go to line 5, right? And it's saying, hey, you're calling this function pick. I've never seen this, I've never heard of it. Now it's going to assume, since I passed a value of 2, and 2 looks like an integer, it's going to assume that this function wants an integer. And since I'm putting the result into this variable that's declared to be an int, it will assume it's returning an integer. But don't make your compiler make assumptions, right? That's a pathway to misfortune down the road. So what we do is we write a function prototype. So we tell the system what our pick function is going to look like, and we do it like this. And if you want to put an argument here, you can do that, and it's useful in prototypes sometimes because that helps you, remember what the argument's going to be. But in fact, you can do it just like that, and it'll work perfectly fine. So either way. So now I can compile my program again, and when I run it, I can see, why I didn't get 10 out of 10. Because hey, for some reason my pick function is always returning 1. Right? So this is way more useful than just going into assess and seeing, 0 out of 10. Because assess will not give you a whole lot of useful information. So you got to make your own testbed function, your own main program, and you can make that whatever seems useful to you until you figure out, oh, yeah, this should be returning a 2 and a 3 and a 1, and it's just returning 1 every time. So something's wrong with my pick function. So you go back in, it's like, oh, I deleted all my code that I had before with the modulo and stuff like that, right? So go ahead and change your pick function to one that does the right thing, and then let's go ahead and compile that up. And now if I run my test bed, hey, it looks like it's doing the right thing, right? 2 gave me back 2, 3 gave me 3, 13 is one more than a multiple of 4, so that gave me 1. These are multiples of 4, and it gave me back 1. Okay, this looks more reasonable. So now I'm going to go ahead and reassess. So I'm going to put my output in an executable called pick. I'll do pick.c, and I'll do the testbed / temp odp410 main.o. And then I'll assess pick.c. Grade it, there's your 10 out of 10, you're done. So to assess the code, you link the ODP to a test program that runs values through the ODP. To test it yourself, you link your program to your own main program and test the values. So so this was my test program that I was using to exercise my pick function. So you can use that to test your code, and then when you're done, you can go ahead and link it to the main test bed. And use that through the assess command. All right, other questions about that?
So this is similar to like a header, right?
In a sense, yeah. So ODP410 main.o is a precompiled main program. It's something like this, but instead of giving you the source code, I've given you a compiled version of it. We'll talk about what a .o file is in a second. But it's basically my version of a test bed. But it doesn't help you debug, because unless you know what the source code is, you don't know what the output should be, and so you don't know, how to relate the output to what you're expecting to see. So that's why you have to write your own main function. The nice thing is this spares you from having to do things like, get the output exactly correct, or make sure that you have, a new line at the end, or all of that stuff. Because your pick function does not produce any output. It does not read any input, right? It's got a very precisely prescribed set of behaviors, which is, take an argument that's an integer, etc., etc. So it's easier in that sense to follow the assignment when what you're writing is a function instead of a main program. So let's talk about this business of .o files. And basically, when you start off with a C program, like pick.c, you can compile that into what's called an object by saying gcc-c pick.c, and that gives you a pick.o, which is an object file. I always call them object modules, but we'll just call it an object file. And it's binary code. It's compiled C code, but it's not executable. You can't run it. It'll say permission denied. If you change the permission, it'll say it's not a valid executable format. And if you have another main.c, you can compile that with gcc-c main.c and get yourself another object, main.o. And you can do this with 50 different files and have a bunch of .o files. And then these can get linked together by doing something like gcc-o main, main.o, pick.o. That would give you an output file named main, which is executable. Now, if you're starting from .c files, you also have the option of just saying gcc-o main.c, pick.c. And this one line does all of that. It takes this, it compiles it to an object, it takes main, it compiles it to an object, it takes those objects, links them together into an output file called main. But we can also do this in a more nuanced, piecemeal way. And there's some good reasons for doing that. So here's what I have so far. So I've got my main.c and my pick.c. I can say gcc-c main.c. And I can say gcc-c pick.c. And now I've got two object files. And if I want to combine those into an executable, I can link those two .o files and make myself a main program. Now, why do we want to do that? That's a topic we'll come to later related to something called Makefiles. The basic idea, though, is that suppose you're working on a big project where you have 100,000 .c files that are all going to get tied together into one executable. And suppose you make a change to one of those files. There's a 5-line file called, minifile.c. And you make a change to that because you had a typo inside. If after you make that change, you do something like this, where you say gcc right? If you do something like this where you link, 100,000 .c files together to make your executable, you're asking GCC to recompile all of these files that you haven't changed. And that can take a long time. That can take days. Probably more like hours today, but So if you're going to work with a large set of files and you might make a change to one of them, it's a lot more efficient if you just recompile the one file you changed to a new .o file and then go ahead and link those .os. And doing this, linking a bunch of .os into an executable, is pretty fast. Doing this, where you're actually recompiling source code, that can take a really long time. Because you might have, 10 million lines of source code, and that's just a lot of processing for GCC. So it's a time efficiency. And we'll talk about Makefiles in a few weeks and do some specific examples of this, but that's where we're going. For us right now, all you need to know is that .o file, that's just the name of the testbed, /temp/odp 410 main.o. That's exactly what a Makefile is. Yeah, it's an automated compiling script. Because again, think about 10,000 or 100,000 .c files being put together, and files being included and so on. If you change one file, what has to happen to make your new executable? A Makefile basically stores the recipes involved in creating an executable program. And so with a well-made Makefile, right, if I make a change, if I fix my pick.c program and I want to rebuild my executable, all I have to do is say make and just hit enter, and if I had a Makefile, it would go ahead and rebuild my executable in a way that's very efficient. I do remember when compilers got too fast, and that I used to enjoy, going out and getting a soda while my program would compile. And I remember when they got to the point where you didn't get a break anymore because none of your programs took, 5 minutes to compile. And so that's kind of a bummer. But yeah, we could get back to that with a lot of code. All right, other questions, comments about that? That's more a preview of coming attractions. All right, so let's dig into functions. And we're going to do a lot with functions in this course, and even more so in 222. And technically, you could write your stick program as just one big long program, right? Which is kind of what a lot of people did for Bash, and it's what I suggested doing for Bash. But breaking your code into pieces, into functions, makes life easier. It's an easier way to sort of organize your thought, and we'll talk more about how to relate this to the stick game tomorrow. But let me go through kind of a refresher or background on functions in C, because if you did 121 a year ago, it may be rusty at this point. So let me do a simple main program. And let's I went down the wrong way. Let's make a simple function. All right, let's write a function which will take two integers and tell us which one is largest. So if I call this with 10 comma 20, it should come back with a 20. If I call it with 20 comma 10, it should come back with a 20. And this is not too complex a function to write. You can actually do this in one line if you use a ternary operator. But, oh yay, coffee. But if you were using this function, if you were doing this behavior, 10 different places in your code, you don't necessarily want to write the code for doing this calculation 10 different times. And then maybe at some point you decide, you really need to find the largest of three things, and now you have to go change 10 pieces of code and so on. So we put this in a function, right? So we're going to call this largest function. We'll pass it two numbers. It'll give us back the larger of the two, and we'll go ahead and print that out. And if we try to compile this, we get an error. We get a warning up here because we didn't prototype the function, but we get a hard error later on when we try to link, which says undefined reference to largest. There is no largest function. Okay, so let's fix the prototype error first, because we're going to want to prototype this. So my prototype would be something like that. It's just telling the compiler, hey, when you see this, expect two integers, return an integer. Okay, so now if I compile it, it actually compiles fine, but I get this error, and when you see this weird thing with a funny name in it, that tells you that this is not a GCC error per se. It's coming from somewhere else. And main.c text plus hex 13, what does that mean? Well, here's the part to pay attention to. Undefined reference to largest. And collect2 error LD returned 1 exit status. What does that mean? What is LD? LD is the linker. That's the thing that puts your objects together to create an executable program. So this is a linker error. And that makes sense, because when I compile this program, right, I don't have to put the largest function in here. I can put it in a separate file. So compiling is fine. But the assumption is when I try to build an executable, this is somehow going to be specified somewhere what the actual code for largest is. So in this case, we do have a main program, but we're missing the function largest. So yeah, we do have a main program. So let's go ahead and make our largest function. So uninspired choice of variable names here. So if A is bigger than B, I'm going to return A, otherwise I'm just going to return B. So there's my largest function. Now if I try to do this, then we get to what someone asked in chat, right? Which is that, again, it compiled, but I got an error from LD, from the linker, saying undefined reference to main. If I try to compile largest.c into an executable, it says, hey, where's your main program? Well, my main program is in main.c. Alright, so I can tie these together by doing this. And you can always just, put in the .c files. We can do .os if we want to be efficient, but we'll just do, main.c, largest.c, that's the two source files. Compile those, link them, make the output file main, and then we can go ahead and run main. It says the largest value is 20. All right, so how does this work? What's actually happening here? The first thing is C is a really simple language in terms of syntax. If you look at a description of the syntax for C, it's a couple of pages long. It's hard to learn, but it's not complex in the sense of the rules that describe what a valid C program is. It's a pretty simple syntax. And things like printf are not actually part of that syntax. Pretty much anything that C doesn't recognize is likely to be a function. So printf is a function. Largest is a function. And even without the prototype up here, when the compiler gets to this line of code, it doesn't know largest as part of the C language. It's going to assume it's a function. And the prototype is really to tell it what types of arguments it's going to take. So most of your C program is function calls. So there's two things we do with functions. One, we can choose to pass them information. You don't have to. But in this case, I'm passing two numbers to my largest function. So you list your arguments with commas in between. And since our function is expected to take a pair of integers, I can just put integers here, or I could have variables that were integer variables and give those values and list them here. Or, I could have an expression here, like that. As long as the value ends up being an integer, that's what will get passed to this function. Yeah, so C++, I don't know the full history of why somebody decided to add objects to C, but C, has generally been a very popular language. It's just almost certainly the most used language now, since it's, that's what all this stuff is written in, that's what Java is written in, and so on. So I think when people started exploring object-oriented methodologies, probably a lot of people had the idea of, we should put this in C. And A and B we don't use anymore. But yeah, there were earlier versions of C, and every now and then something will jump up that's like a holdover from one of those. I got caught on something over the spring, I think, on an Arduino where there was an order of precedence operator around logical booleans versus bitwise booleans, and it made no sense, and I looked it up and it turned out it was a holdover, I think, from the B language, that they just kept for backwards compatibility. So yeah, there's weird things now and then. I don't know if C++ is available from C-Tech. We don't teach C++ in the CSE sequence, but we teach Java in 223 as an object-oriented course. Um, and if you know Java, you can do C++ pretty easily. If you know C++, you can do Java pretty easily. It's more the jump from kind of old school languages like C and such to something object oriented is the bigger jump. Um, yeah, I read a little bit about the C with classes naming. Yeah, it's cool history. Um, what if you had two functions, each in their own files, and you wanted one function to have access to the other? Would you need to link them together? Would you just need to link them to main? Um, Presumably, everything's being tied together into a main program. So I would do, gcc-o main.c, function1.c, function2.c, for example. And the linker will figure out how to put all those pieces together. All right, so this is calling our function, and when you call the function, what happens? This code starts to execute, but before this code executes, the variable a in this case is given whatever the value of that first argument was. So a would be set equal to 10, and the variable b would be given the value of whatever the second argument is. So the compiler will generate code, or maybe just calculate 4 times 5. This will end up being a 20. And so when this code starts executing, a will be equal to 10, b will be equal to 20. And then it does its business. And when there's a return statement, if we return a value, that value basically takes the place of this. So if that call to largest executes a return 20 statement, this basically has the value 20, and this whole statement becomes integer answer equals 20. And then when we print out answer, it prints a 20. All right, so that's the basic interaction between functions and things calling functions. And you can call with no arguments, or you can call with one or more arguments. You can use a return value, or you can ignore a return value. You can, in your function, just say return, and if you say the function is void, it'll just return. It doesn't actually give you a value back. What does programming classes and object-oriented means anyway? So that is a whole class in and of itself. If you're familiar with structures, then you've got a handle on what classes are. Classes are kind of like C structures, but with a little extra stuff. And we'll talk about structures later in this course, but we'll talk a lot more about structures in 222, and then in 223 we'll dig into object-oriented programming. But it's really a way to sort of take like things that belong together and bundle them into one piece. So you can make a structure called point that has like x, y, and z coordinates, and that gives you a structure. But if you also add, like a function that tells you the length of a vector starting at the origin, ending at that point, and you also have a function that will normalize that vector and give you back a vector, right? And you put all of those things into that structure, now you've got a class. So a class is like something that combines data and code into a single kind of logical unit. All right. What are some situations that warrant considering making a C header file? I'm going to say for now, let's not do C header files. When we talk about Makefiles in a few weeks, we'll get into .h files and making a .h file. But it's too easy to put the wrong kinds of things into a .h file, and it feels like once a student does that, they never are able to stop, and it causes problems down the road, especially with like teamwork. So I'm going to stay away from header files for now, but the short answer would be things like function prototypes. Those make sense to go into header files. And if I had a lot of things where I had to write the same function prototype over and over and over, I would just throw it in a header file. But we'll work with that in a few weeks. All right, so you know, you can pass whatever you want as long as it evaluates to an integer. If
Are
you
you okay with us using other header files though, like standard library?
sure, definitely.
Okay.
So if I try to call largest with like 3 things, and I try to compile, I get a pretty reasonable error message. Too many arguments to function largest, right? And it says down here, so this is line 7, right? I'm calling largest, but on line 3, I declared my function like this, which only takes 2 arguments. Right, and that's you know, you couldn't really ask for a more pleasant error message, right? It's got some good, you know, alarming red here and so on, but too many arguments for function largest. And you know, line 3 is right here where I prototyped, and line 7 is right here where I used it. And if I do it like this, right, with only 1 argument, it says, hey, error, too few arguments. You're calling it like this on line 7, you declared it like this on line 3. When you're linking files, the order does not matter, except remember absolutely that when you say -o, the output file has to go right after the -o. So those always have to be side by side. But I could do pic.o, main.o, I can do main.o, pic.o, the order doesn't matter. Unless you have one function declared in multiple files, which is a kind of iffy thing to do, but it'll do first come, first serve. Yeah, do me an attendance ping since we're close to the end. And let me know you're still here. All right, so other questions or comments about functions in C? And what I'd like to do tomorrow is 2 things. One, talk about how we can use functions with our stick program, for example, to sort of modularize it, to break it down into logical pieces that we can use to make our code look a little simpler and therefore be a little easier when we're developing it. So that's one thing. The other thing I want to talk about is how we pass arrays. And remember, arrays are that's how we implement strings. Strings are a special instance of an array. It's a character array. So we're going to want to be able to pass arrays to and from functions. So we'll talk about that a little bit, and this will move us towards demystifying this whole char star star argv business, and we'll see what that's all about. So we'll do that. I'll probably put another ODP up tomorrow, and we'll look at that. But that should do us for now. So if I don't see you in 2:15 this afternoon, I'll see you tomorrow in class. Have a good afternoon. Thanks.
Hey, Nick, can I ask you a quick question for compiling? Remember, usually we do GC